Hello guys, welcome to videos of and tutorial. Thanks for watching our videos online. Please welcome subscribe. Please do it, press subscribe button and notification bell and answer our updates on this YouTube channel. Thank you and God bless you. Amen. Now today I'm going to be considering what? Chemistry. Another topic called mole concept. I've already uploaded the slide of this topic on the YouTube channel, but I felt that I need to do justice to this in terms of one-on-one teaching. And here we have mole concept. Now I'm talking about mole concept. It has to do with the means of measurement in chemistry. Now, for instance, now we measure mass in gram. We use what? We use weighing balance to weigh what? To weigh mass of a substance, or we can use digital balance. But when it comes to what? Particles like atoms, molecules. When it comes to particles like atoms, molecules, and ions of substance or matters. Now, when it comes to atoms, molecules, or ions contained in matter, they are very small particles of a substance that cannot be measured with a weighing balance or measured with what? With a volumetric what? Flask or with a cylinder. Now, there's the place of what? Then comes to a place of what? Mole. Now, we use mole to measure what? Atoms, molecules, and ions contained in a what? In a matter. So, if you want to know the what? The number of atoms, molecules, and ions, we use the principle of what? Mole concept in chemistry. So, really that's what we want to measure things at electroscopic level. You need to use the concept of moles. If you want to measure something that are in electron levels, we use the concept of mole. And what do you mean by mole? Mole has to what? Mole is a unit of what? Of measuring. The unit of measuring, or the unit of measuring particles at microscopic what? Level. Just take it like that. The unit of measuring particles at microscopic level. And before you could get the what? The actual or the formula used in calculating mole, we need to know some basic what? Basic terms, which are number one, the RAM, which I call RAM, which is the same thing as well, the relative atomic mass of what? Of an element. Now, we're talking about the what? RAM of an element. It is what? The relative atomic mass of an element. And mathematically, it is defined as the what? As the number of times the average mass of what? Of an atom of an element is heavier than 1/12 of one of the atom of carbon-12 is what? Is heavier than 1/12 of the mass of one atom of carbon-12. Actually, that's how the definition of what? Of relative atomic mass. It was defined based on what? On carbon-12. Based on carbon-12, it's like we considered what? The relative atomic mass based on the mass of 1/12 of one atom of carbon-12. But in a simple statement to avoid controversy, relative atomic mass of an element is simply the weight of that element. Is simply the weight of that element. That is the weight of the atom of that element. For instance, if you consider e.g. oxygen. Now, oxygen gas, we represent oxygen molecule as O2. Oxygen molecule, chlorine gas, oxygen gas, nitrogen gas, they are in form of molecule. They are not in a single atom. They are in form of molecule O2. They have Cl2. Now, if you now ask what is the relative atomic mass of oxygen, now O2 contains two atoms, which is oxygen plus oxygen. Now, when I talk about relative atomic mass, it is with a single atom of an element, which is what? Which is the single atom, the weight of one atom of that element. So, the relative atomic mass can be simply defined as the weight or the mass of an atom of an element, the mass of an atom of an element. So the mass of an atom of an element now is of this oxygen, which is what? Which is oxygen atom, is 16 grams. So now the weight of the relative atomic mass of an element is the weight of the or the mass of an atom of that element. So the weight of oxygen is 16, the weight of oxygen atom is also 16. But when they are in molecule, because it's made of 2 what? Oxygen, and they become what? 32 what? Gram. But individually, when they are in its atom, they are what? They are 16 gram each. But in molecule, when they are in a molecule, they are 32 what? Gram. Please note that, because it's very, very essential to know the relative atomic mass of an atom of an element, which is what? Which is for oxygen 16. But when it is in molecule, they usually use 32. So don't mix it up. Now, we have the relative atomic mass of this element. The relative atomic mass of this element, for instance, we have what? We have hydrogen to be what? 1. The relative atomic mass of hydrogen is 1. They usually put it on the top. It is 1. Helium is 4. Lithium is approximately 7. And so on and so forth. So you must know this, that sometimes you need to know this offhand, so as to be able to recall it for some calculation in the exam. So we have hydrogen is 1, helium is 4, lithium is 7, oxygen is 16, I've jumped, chlorine is what? 35.5, and so on and so forth. We have what? Copper, and so on and so forth. So now let's move to what? Another concept that we need to know for us to be able to calculate the mole of a substance. We need to know the relative atomic mass of that element contained in that substance. Now, number 2, we have to know the relative molecular mass. The relative molecular mass. Now, the relative molecular mass has to do with what? Has to do with molecule, or we can also refer to as what? Compound. Now, this relative atomic mass RAM, this with what? This with the relative atomic mass, this with elements. But this one, this with what? Molecule. Just as I've already said in the previous example, like O2 here is a molecule. So this relative molecular mass, this with what? Molecule. 2 or more what? Compound. Chemically combined together. Now, molecule is now involving more than one atom. It's involved more than one atom. For instance, now oxygen is a molecule because it contains 2 atoms, O plus O. So we call this one homogeneous what? Homogeneous molecule. Homogeneous molecule. We call this homogeneous molecule. And we have heterogeneous molecule, which is CO2, like when you have this carbon, C plus O2. So this one, we have heterogeneous. So they are homogeneous because they have the same atom. This is heterogeneous because it has carbon and what? Oxygen. So this is heterogeneous what? Molecule. Now when we are talking about what? Now, relative molecular mass. Relative molecular mass is just simply the what? The sum of individual mass of atom contain the sum of all individual mass of atom contained in a molecule is just the sum of the individual masses contained in a molecule or compound. Now, what does that mean? If I want to calculate the relative molecular mass of what? Of oxygen now, just add 16 plus 16. This will give you 32 grams. Meaning that what? 32 grams here is the relative molecular mass, while 16 grams is the relative what? Atomic what? Mass. So, if I want to calculate the relative molecular mass of carbon 4 oxide, it will be what? Relative molecular mass of carbon 4 oxide will be now what? This is what? 12. And this is what? 2 into brackets what? 16. Because 1 oxygen is what? 16. So 2 times 16 will give me what? 60. What? Will give me what? Will give 2 times 16 will give me 32. And this one will give me 12. So this is 12 grams. Why this one is what? 32 grams, because we have what? We have 2 oxygen. Now, the relative molecular mass of this compound will have just 12 grams plus 32 what? 32 grams. So this one will be what? 44 grams. So the relative molecular mass is just the sum of every individual masses of an atom in that molecule. That is the sum of this with this. Then the result will give us what? The relative molecular mass. So don't mix it up. This one has to do with molecule or compound, and these two or more atoms in a compound. While this one has to do with what? A single atom of an element. Just as that. So now, how does this relate with our mole? It relates to our mole because mole is divine. Mole is divine as the ratio of mass of a substance. Is divine as the ratio of mass of substance or of mass of particle. The mole of a substance is defined as the ratio of the mass of that substance. Defined as the ratio of that mass of that substance all over the relative molecular mass, also known as what? Relative molecular mass, all over the relative molecular mass, all over the relative molecular mass. Now, the mass of a substance all over the relative molecular mass, or so I might call it what? This bracket molar what? Molar mass. Please note that. Relative molecular mass is also known as what? Relative molecular mass is also known as what? Molar mass. So they are the same thing. So what this thing has to do with mole is that they are the one that form the what? The formula for mole. Mole has to be divided as the ratio of the mass of a substance all over the relative molecular mass. That is mass all over what? Molar mass. So that's how you calculate mole. And there are some things before I go into calculation that you need to know. 1 mole of any given substance is equals to 6.02 times 10 to the power 23 Avogadro's constant. Note that it's very, very important. 1 mole of any substance, whether it is oxygen, whether it is chlorine, whether it is what, whether it is any compound, 1 mole of that substance is equivalent to an Avogadro's number, which is also known as Avogadro's constant, 6.02 times 10 to the power 23. Please note that. Note that 1 mole of any substance, any what? Substance, be it compound, be it ion, be it what? Atoms, be it molecules of any substance is equal to or contain 6.02 times 10 raised to the power 23 of that particles. 1 mole of any substance is equivalent to 6.02 times 10 raised to the power 23 Avogadro's, or let's just put Avogadro's number. So that's that about that. So now question number 1 says that the number of atoms present in 5.85 grams of sodium is, now listen, the number of atoms present in 5.85 grams of sodium chloride. Number of atoms, note that solution. You have to calculate number of atoms in 5.85 grams of sodium chloride. Number of atoms present in 5.85 grams of sodium chloride. They are looking for number of atoms. Whenever you are hearing number of atoms, number of ions, number of what? Molecules, they are referring to what? To the particles contained in that what? In that substance, which is we are going to use what? Avogadro's what? Number. That's why Avogadro's number is expressed. It can be expressed in 6.02 times 10 to the power 23 molecules, ions, or atoms. So, and I've told you that 1 mole of that substance contain what? 6.02 times 10 to the power what? 23 molecules, ions, or what? Or atom. Now, note that these molecules, atoms that we are talking about is not something that is ambiguous. They are just form of particles that can exist in a substance. They are form of particles that can exist in a, like if I take what? If I take this marker for instance, there are some particles like atoms, ions that are made up of the ink of this what marker. They are made up of the constituent of these plastics. So don't look at it as an ambiguous thing. It's something that is what is the component of any what matter, ions, atoms, or what, or molecules. Now they now ask us to calculate the number of atoms in 5.85 grams of sodium chloride. And how do we go about it? The first thing is to what? First look for 1 mole of sodium chloride. So you have to say, okay, 1 mole of sodium chloride. 1 mole of sodium chloride will contain, because we said 1 mole of any substance is equivalent to 6.02 times 10 raised to the power of 23 atoms. Do we agree with that? That is, every 1 mole of what? Of a substance is equivalent to 6.02 times 10 raised to the power 23 what? Atoms. Now, if that be the case, then well, we are given the what? We are given in terms of gram. Listen, we are given this in terms of what? Gram. Now, then there's a way you can do this in such a way that you either convert this to mole, or you use what? The gram, you convert this 1 mole. You either convert this one to mole, you either convert this gram to mole, or you convert this mole to gram, so that they can be on the same unit. Is that you listen? Is that you convert this what? This gram to mole, because this is a mole, or you convert this mole to gram. Depends on what you want to do. So now, what should we do now? Let's try and convert this 1 mole to what? To gram, so that we can have it in gram. So, and how do I convert what? 1 mole of a substance to gram? How do I convert 1 mole of a substance to gram? Just come here. Now, you know that this 1 mole of sodium chloride. So just come here. 1 mole of a just note 1 mole of a sodium chloride, or 1 mole of any substance, is the same thing as its molar what? Mass. But because we are dealing with compound here, it's going to be molar mass because it involves 2 atoms. Molar mass is for 2 or more atoms, while atomic mass is just for what? 1 atom. So please don't note that. So 1 mole of sodium chloride is the same thing as molar mass of what? Sodium what? Chloride is equal to the molar mass of sodium chloride. That is, if you want to get 1 mole of sodium chloride in gram, you have to find the molar mass of that one, sodium chloride. So what is the molar mass? That's why they give us all these things. So that's why they give us sodium is 23. The molar mass, the atomic mass of sodium is what? 23. So what they give us here is atomic mass. Atomic mass is one that will add up to get to what? Molar mass. So sodium is 23 and it is 1 plus what? 35.5. That is chlorine. So add it together, we are going to have what? 58.5 gram per mole. But because you are using what? Gram only here, just leave it as gram. You use gram per mole in volumetric what? Analysis. But leave it as gram. If you use gram, nobody will penalize you for that in this what? Aspect. Now we have what? 58.5 gram. Now we have converted 1 mole of sodium chloride to 58.5 gram. So we have converted. So what we are going to do now is instead of having 1 mole of sodium chloride equals 6.023 atoms, 6.02 times 10 times 10 raised to the power 23 atoms, we are now going to have 58. Don't forget that we are coming back to this. Instead of having 1 mole of sodium chloride, now we now say 58.5 gram of sodium chloride is equivalent to 6.02 times 10 raised to the power 23 what? Atoms. So instead of us having 1 mole now, we are now having what? We are now having 58.5 gram of sodium chloride. So now bring this down. 5.85 gram of sodium chloride now. We now control how many atoms now. Just, you can make this test, but because of our time, just multiply this and divide by this. So this one will be 5.85 times 10 raised to power 5.85 times what? You multiply, as soon as you multiply this, then you divide it by this. Do you get that? Multiply this and this, then you divide it by this. So we have 5.85 times 6.02 times 10 raised to power 23 atoms all over 58.5 gram. So now, if you can see it very well, you can see this gram will cancel gram, and this one, 5.85 here is 1. 5.85 in 58.5 will give you 10. So 10, this 10 will go because of I don't have a calculator. You can use your calculator, but let me just do it in form of law of indices. This one will come up, and this one is power of 1. If it come up, it becomes minus 1. It's law of indices. But if you don't know how to use, just use your calculator. So this one goes up to be up minus 1, so it will go 6.02 times 10 raised to power 22 what? Atoms. So that's that about question number 1. Please let's be fast about that. Now I told you can convert also this one to mole by just using 1 mass over molar mass. Just 5.85 divided by 58.5, it gives you mole. So after getting that mole, just put it here. So what I'm trying to say is that if you decide to convert it to mole, if you decide to convert this 5.85 to what? To mole, it will be what? It will be what? Mole equal to what? Mass over molar mass, right? If you decide to go by the second method, mass over molar mass. So that is the mole here. Mole is equal to mass over molar mass. So what's your mass that you are given? 5.85. All over. What's your molar mass? 58.5. So it will now give us 0.1 mole. To give you 0.1 mole. So since you have gotten the mole of this, you just come back to this. You now say 1 mole of sodium. 1 mole of sodium chloride is equivalent to 6.02 times 10 raised to power 23. Then 0.1 mole of sodium chloride now will be equal to what? You multiply this 0.1 times 6.02 times 10 raised to power 23 divided by 1. So if you multiply it like this, you still see you are going to get 6.02 times 10 raised to power 23 atoms. Sorry, it's not 23 again. 0.1 times this is 22 atoms. Can you get that? 1 mole of sodium is equal to this. 0.1 mole of this is what? So that is the same thing that I want to get. Depends on the one. You can decide to go by this or by this. So let's quickly go to the one. Question number 2 says that in the reaction below, how many electrons are transferred for each mole of copper produced? In the reaction below, how many electrons are transferred for each mole of copper produced? Now, in the reaction below, that's question number 2. They have 3 copper 2 oxide plus 2 moles of copper of ammonia to give what? 3 copper solid plus 3 moles of water plus nitrogen gas. Please note this. Note this. The first thing is to look at your formula. Look at this number here. Represent number of moles used. Number of moles of copper oxide compound used is 3. Number of moles of ammonia used is what? 2. Number of moles of copper obtained after the reaction is what? 3. And number of what? Water and oxygen obtained is what? 3 and 2 respectively. Now, you know that what? In this reaction, the concentration here is the copper produced. Know that. That's what the questions, the emphasis is on. Now, the emphasis is on copper produced. So how many copper produced is here? How many copper is produced here? How many copper solid is produced here? 3 mole of copper solid is produced. Now, the next thing, for each mole of copper that is produced, how many electrons is transferred? Note that electron is one of the particles of a substance. So I will use Avogadro's number as a standard to measure the number of particles in a substance. We use Avogadro's number. We want to calculate the number of electrons, number of ions, number of molecules, number of atoms. We use Avogadro's what? Number. So you now come here. Since we have 3 moles of copper now, you now say 1 mole of copper solid is equivalent to 6.02 times 10 raised to the power 23. Now, electrons, that's the particles we are considering. So that's how I'm using the electrons. So, how much with 3 moles of copper will be equivalent to? Now, 3 moles of copper, let's cross multiply. That's 3 times 6.02 times 10 raised to the power 20 what? 3 electrons divided by 1. Simple. This one will multiply this one, divided by this. This one will do what? 3 times this now will do what? 60.18 times 10 raised to the power what? 23 electrons. If you want to convert it to what? Standard form. If you move this one backward, it becomes positive. 1.806 times 10 raised to the power 1 times 10 raised to the power 23. So when I add them together, it will be 10 raised to the power 24 electrons. Okay, let me write it here. 1.806 times 10 raised to the power 24 electrons. Please note that. So that's that about question number what? 1. Question number 2 rather. So this is just, if you don't know how to do this very well, you can use your calculator. So you have 3, that's law of indices. And number 3 questions, the number of molecules of carbon 4 oxide produced when 10 points So question number 3 says that the number of molecules of carbon 4 oxide produced when 10.0 gram of calcium triazocarbonate 4 is treated with 1 molar of LCl in equation below. Now they said number of molecules. Please note that number of molecules. So we are going to use Avogadro's number because of the number of molecules of carbon 4 oxide. That's another way of concentration. When 10.0 gram of CaCO3 is treated with 0.2 centakib of 1 molar of HCl, very, very tiny amount of what? HCl. So what will be the what? Number of molecules of carbon 4 oxide produced? The first thing is to write the formula first. HCl, to write the what? The equation of the what? Reaction. CaCO3 plus what? No, CaCl2 according to the plus COCO2. Now H2O. This one has 2. Now from the what? Chemical reaction, analyze the number of moles. This one is 1 mole. In relation to what? In relation to carbon 4 oxide, how many moles is this one? This one is also 1 mole because this is 1, this one is also 1. Note that the coefficient here is 1, the coefficient is also 1, so that is 1 mole. So 1 mole of CaCO3 generates what? 1 mole of carbon 4 oxide. So we write it out, we can write it out. 1 mole of CaCO3 is equivalent to 1 mole of what? Produce 1 mole of what? CO2. It produces 1 mole of CO2. Now, because they give us 10.0 gram, to convert 1 mole of what? CaCO3 to gram. And how do you do that? I say 1 mole of a compound is equal to the what? To the molar mass of that compound. So we find the molar mass of this. And what is the molar mass? The molar mass is what? 40 plus 12 plus 3 into bracket 16. So this one will be 40 plus 12 plus 48, which is 100 gram. Or am I communicating? This one is what? To convert 1 mole of CaCO3 to gram, they have to find the molar mass. So what is the atomic mass of what? Of calcium 40. Atomic mass of what? Of carbon is 12. Atomic of what? Oxygen is 3. Multiplied by what? It's 16. It's 16. Multiplied by 3. It gives us 48. So when add it up, it gives us what? 100 grams. So we have to actually calculate the mole. 1 mole of what? We have to actually change 1 mole of CaCO3 to gram. So this one will now be 100 grams of CaCO3. No longer in the mole now because we have converted it. Will be equivalent to 1 mole of CO2. It's the same thing as 6.02 times 10 raised to power 23. Now, because we are now considering what? Molecules, we not put number, we not put 6.02, we not write 6.02 times 10 power 23 number. Instead of that number, we replace it with molecule because we are calculating the number of molecules of carbon 4 oxide that we what produce. So it will now be what? 6.02 times 10 raised to power 23 molecules of carbon 4 oxide. Now, 100 grams of CaCO3 is equal to 6.02 times 10 raised to power 23 molecules of what? Of carbon 4 oxide. So now, what about 10 grams now? 10 grams of CaCO3 that was mentioned in the questions will now give us 10 times 6.02 times 10 raised to power 23 all over. Now you multiply that and divide by this 100 all over 100. So this one cancel one of the words 0. So this one will have 6.02 times 10 raised to power 23. Now this is power of 1, 10 raised to power 1 times 10 raised to power minus 1 when it comes up. So according to law of indices, so this one will have what? 6.02 times 10 raised to power. Now 23 minus 1 is what? 22 molecules of carbon 4 oxide. So that is that about that. Now lastly, let's check the last question. Now, the last question here, which is question number 4. Question number 4. Question number 4. The last question, which is question number 4, says that the Avogadro's number, 24 grams of So, the last question here, which is question number 4, says that the Avogadro's number of 24 grams of magnesium is the same as that of 1 gram of hydrogen molecule, 16 grams of oxygen molecule, 32 grams of oxygen molecule, 35 grams of chlorine molecules. This is a technical question. We said Avogadro's number of 24 grams of magnesium. Now, you have to understand this very, very well. The Avogadro's number of 24 grams of magnesium is equivalent to one of these. Now, magnesium has the atomic mass of 24. Magnesium has what? The atomic mass of what? 24. So, and we say that 1 mole, listen, 1 mole of a substance is equal to its what? It's equal to the Avogadro's number. And 1 mole of this magnesium is same as 24 grams of magnesium, which is equal to 6.02 times 10 raised to power. So they were right when they said the Avogadro's number of what? Magnesium 24 grams is 6.02 times 10 raised to power 23, which is Avogadro's what number. They were right. So they were not. The question now is which of these options is equivalent to what is given to us? Is equivalent to what is given to us. Now, the first thing now you begin now to cross-check the answers. Now look at this. They said 1 gram of hydrogen molecules. 1 gram of hydrogen molecules. Now, what does hydrogen molecule is 2? Hydrogen molecule is H2, right? These are to represent hydrogen molecules. But you know that 1 mole of this hydrogen molecule, 1 mole of hydrogen molecule will be equivalent to 6.02, right? Times 10 to the power 23. That is 1 mole of H2 is same as 6.02 times 10 to the power 23, which is Avogadro's number. It's correct. That one is correct. But when you change this 1 mole to gram, 1 mole to gram, it will be what? It will be 2 gram, not 1 gram. Because hydrogen is 1, but it has 2 here. So 2 times 1, it will give you what? 2 gram of hydrogen. 2 gram of hydrogen, which will give you, which is equivalent to 0 point times 10 to the power 23. So meaning that what? This 2 gram is equivalent to 6.02 times 10 to the power 23, not 1 gram. So can never be an answer. The same is also applicable to oxygen molecule. Oxygen is O2, and the mass of each oxygen is what? 60 times 2 will give 32. So meaning that this is supposed to be 32, not 16, because it is oxygen molecule. So this one is not correct as well. Now let's look at number 3, number option C, 32 gram. This is what I'm saying. Oxygen molecule will what? It will be 1 mole of molecule also, you know, of oxygen molecule will be equal to what? 6.02 times 10 to the power 23. But 1 molecule of oxygen contains 2 atoms. It will be 2 times 16 now, which is 32 what? Gram of oxygen molecule will be equivalent to 6.0 what? 2 times 10 to the power what? 20. So therefore, it is option C that is equivalent to what? The question given us well, because it's the one that has 32 gram of oxygen contains 6.02 times 10 to the power 23, as well as 24 gram of magnesium contains 6.02 times 10 to the power 23. You can see 32 gram contains 6.02 times 10 to the power 23. Also, 24 gram contains 6.0 times 10 to the power 23. And you are very correct. Here, 23, 22, 24 contain the same number of Avogadro's number. We have come to the end of today's class. If you don't get any questions, to get in contact with us. And if this video has helped you, please do to press the subscription button and the like button, and also the notification bell in order to see our update on this YouTube channel. Thank you for watching once again. God bless you. Amen.